to my next class. We are going to be treating immobilized enzymes. So this is an enzyme that is attached to a material that is soluble, that is insoluble and inert. Immobilizing an enzyme allows for an increased resistance to variables such as temperature and pH. So the enzyme will not be denatured. Of course, we know that enzymes are easily denatured, just like protein. So when there is an increased temperature, or when the pH is somehow increased or thereabout, or some other factors, enzymes can easily be denatured. So if, for example, we are doing enzyme assay, being able to get the true value will be very difficult. So what immobilizing an enzyme does is to make it not to be easily denatured. Now it allows the enzyme to be stationary, just in one place throughout the process, which makes it more easier for them to be separated and reused. Nevertheless, the quality of the enzyme produced largely depends on the carrier type and the process used to immobilize them. Now we have some common processes that are used to immobilize enzyme. We have adsorption, entrapment / encapsulation, that's 2. 3. Crosslinking. 4. Covalent bonding. We'll take them one after the other, sharp. Now absorption, it is one of the simplest and quickest methods of reversible enzyme immobilization. Reversible, it can be reversed. So even if the enzyme has been mobilized, we can also make it not to be immobilized. So this method involves a variety of non-covalent interactions. So once enzymatic activities grows stagnant, those enzymes can be gently removed from the support. Hope you're getting it. So the support can be regenerated and attached to a new enzyme. So whatever support that is used for the immobilizing those enzymes, it can be reused for another enzyme. So the enzyme can be removed and the support will be reused. This can help to eliminate cost associated with the use of support material. Now the process can be completed by immersing the carrier in an enzyme solution, so it can be adsorbed physically, not absorbed. Adsorbed. Now alternatively, the protein may be dried on an electrode surface. Either ways, this method is often preferable because it is cheap to use and does not require the use of an activation reagent. Moreover, another benefit of this method is that it promotes easy contact between the enzyme and the support. Also, there are typically minimal conformational changes made to the enzyme because the mobilization occurs in just a few minutes. So the enzyme will not change its shape. So this leads to high immobilized molecular activity retention. While there are many advantages for using this method, there are also disadvantages to consider. One of the disadvantages is that the method is known for promoting weak links between enzymes. The links, proteins have links. They have links in between, maybe one hydrogen and carbon or nitrogen or whatsoever. So these links that links them will be weak. So the method is known for promoting weak links between enzyme and carrier, which causes substrate contamination. Certain support materials can lead to enzyme denaturation. So certain support material can even lead to, we are trying to prevent the denaturation, but certain material, when it comes to adsorption as a process of immobilizing an enzyme, can cause denaturation. It's one of the disadvantages. 2. The second method of immobilizing enzyme is entrapment. On the other hand, the entrapment method involves covering or caging the enzyme in materials such as polymers, gel, composites, gel, and other inorganic materials. Now we have advantages. Much like the adsorption method, this method is favored because it is inexpensive. It's not expensive. It also allows for increased mechanical stability and makes for easy contact between the substrate and enzyme. There's also very good contact between the substrate, the material you are using, and the enzyme. However, unlike the adsorption, this process is irreversible. Remember, the adsorption method is reversible, so you can always reuse the material you use, support material. But in this one, once the immobilization has been done, both the support material and everything is useless, so you cannot reuse. Now, there are disadvantages of using this method too. One of the disadvantages is the small matrix pore size reduces the mass transfer of substrate to enzyme. 2. It has big pores, big ones that allow for carrier leakage. 3. This process promotes low loading capacity and material abrasion. However, this can be solved by cross-linking. So we are going to the third method of immobilizing enzyme, which is cross-linking. This is a lesser mentioned irreversible, it's also irreversible, a lesser mentioned irreversible method of enzyme immobilization, also known as copolymerization. This does not require the use of support as a means of preventing the loss of enzyme into the substrate solution, also known as carrier-free immobilization. In this method, the enzyme on its own, the enzyme has its own carrier. So it has an advantage. It also has advantage. We said this does not require the use of support medium. It's one of the advantages. It also has disadvantages. Now, part of the disadvantages is that, however, disadvantage lie in the fact that the enzyme being used are often not pure. And we remember it's irreversible. Also, the reagents used are known for modifying the enzyme, which can lead to a loss in general characteristics property. We said in the first one that the shape of the enzyme is not changed, but in this one there can be a lot of deformation. 4. Encapsulation as a method. It involves enclosing the enzyme in a membrane capsule, which is made up of semi-permeable material such as cellulose. The overall effectiveness of this method is based on the stability of the enzyme being used. This method is advantageous because it is inexpensive. It is not also expensive, encapsulation, and allow for large amount of enzymes to be immobilized. Of course, that is what we want. However, the disadvantage of this method is that it has limitation in terms of pore size, and that only small substrate molecules are able to cross through the membrane. So big molecules cannot cross through. 5. Covalent bonding. It is one of the most widely used methods of enzyme immobilization. Covalent bonding. Okay. This irreversible method process involves covalently binding proteins to insoluble support materials formed between enzyme, amino acids, residues, and functional groups of carrier surface. So we'll go to the next one, intra and inter-subunit bond. Now, this method make it possible for the enzymes to be reused in more cycles than the other immobilization methods. This method also assists in the prevention of enzyme leakage in reaction environment. The results of this process are exceedingly pure and have an increased level of thermal stability. It's not affected by heat. While this is by far the most favored method of enzyme immobilization, also has a very notable disadvantage. In particular, this method of covalent bonding, it causes a decrease in enzyme movement. That is one of the disadvantages. Decrease in enzyme movement can also contribute to conformational changes. So, when this immobilization is being done, combination of methods are being used. We have benefits. One of the benefits is reuse and recovery, cost effectiveness, very versatile, etc., etc. Then it can be applied. Immobilization of enzyme can be applied in food industry, brewing, beverages industry, pharmaceutical